professor Arnoldo Frigessi først ut. Han professor på medisin, samarbeider tett med matematikere og statistikere på det matematisk-naturvitenskapelige fakultet, og han skal fortelle litt om hva de driver med. Det skal ikke jeg si noe om. Vær så god, Arnoldo.
Tusen takk, Morten.
Podiet ditt.
Takk. Veldig hyggelig å være invitert her, og etter min første setning på norsk, I speak English. Let's start from this thing here, right? Big data. So, if I ask you, on what day should you buy your airline ticket? You know the answer? Yes, we know the answer. It's Tuesday. If you all start to do it on Tuesday, we have to change our analysis. But this is based on a big study made by Expedia, where they have analyzed 1.3 billion airfares. A big data set that gets an answer, a solution that we are interested in, Tuesday. If you want to know how many days in advance you should order your ticket or book your ticket if it is an international flight, then the answer is 100. More than 3 months. It's difficult to take decisions so early, but in case you can, you know that's the best point. The prices run up after that. It's interesting, a small jump in the last 2-3 days. There is still a little gain to do if you do it properly. All this is based on a careful statistical analysis of a big, big data set. Big data are everywhere. In medicine, that's where I'm working on, there's lots of health data. Every patient produces a journal, and these things are electronic now. They are made of text, images, videos, sounds, lots of unstructured data, including the genetics of individual patients. Why are we interested in all this? Well, because this has to generate knowledge and fast. And it can generate knowledge and fast. Because the usual way of progressing science is by doing very careful small studies where you check people carefully. But this takes too much time and costs too much. Instead, we use all existing data, and this is much more powerful and generalizable. And then this gives something to patients because it increases patient safety. It gives information to health providers. And it leads to personalized medicine because we are able to use the individual genetics that you have, your lifestyle, the way you want to do your future life to decide what therapy is best for you. And I'll try to say a little bit more about this. But we are swimming in data, right? And you know these numbers, Google, Facebook, and YouTube. There's 1 hour video every second uploaded on YouTube. And in our center, I'll say something about this in a minute. Our partner Telenor has a company in Pakistan where there are 40 million clients that use a mobile phone. And if I take 1 month of their data, this is about 6 terabytes. It doesn't fit in this computer and in none of the computers we have here. But before I tell you a bit more of this, I want you to follow me some steps back in history. So who are the leaders in the world? If we go back to the feudal times, it was the knights. And if we go to the industrialized societies, it was the bourgeois. Guys like this, right? And what about now? What about in the information society? Who are the leaders here? Well, it's good news, it's you. It is the universal, educated, and connected human being. The guy with a t-shirt that is liberal, that wants a better world, and that puts all his life, all the time, on internet, online, for everybody, and forever. This is the leaders, it's you. It means that you have a responsibility and a fantastic chance to be part of this. How? Well, you have to learn to integrate data, to put data together from one side to the other. You have to put data together with knowledge. You have to be a piece in a melting pot of disciplines where faculties disappears and mathematics and laws and medicine become just one big book, as it was maybe many centuries ago. But this is where the future is. And because I'm a statistician, you have to do statistics. The success of Norway is based on the fact that down there is petroleum. And the fact that we have the technologies and the capacities to get it out. And the future, what about when the petroleum is gone? We will hear more about this today. Well, then there are data. Yes, there is data down there. But then again, you need the capacity to get something out of it. And yes, it is statistics. So this is my call for action. Take care of doing all your statistics course properly. It is not enough to crunch data. It is not enough to have data. You need more. And this is what the economist tells us, for example, that without the right analytical methods, more data just gives a more precise estimate of the wrong thing. And what we do is model-based statistics. We are using statistical mathematical models to learn what is inside data, to understand mechanisms, systems, the society, to discover things, to predict things, and also to control things. And we have a center called Big Insight, with many participants that tries to do this in some directions I'll tell you more about. We are looking to two specific themes, personalized solution and forecasting the transient. And personalized solution is something I'll tell you about now. Now, given the genes of the patient, just one individual patient, can we predict if this drug is going to work or not? There are many drugs that only work for maybe 20% of the patients, and we don't know why. So can we predict the success right in front giving the drug? Or, given all we know about a taxpayer, do we know if he is really paying all his tax or not? Yes, these problems look different, but they are exactly the same for us statisticians. Here is our data. Big matrix of data. We have lots of people here. Here is Angela. And this is columns where we collect everything we know about everybody. Many genes, many genes. Or in this example, is it? Yes, it's the text, a lot what we know about their behavior. And the question is, does Angela pay tax or not? We don't know this. But luckily, we have some people where we know the answer. Here we know the answer. And out of this, we can learn a rule and apply the rule to Angela and decide that, yes, she pays tax. Or is it maybe genes? Here it's genes instead that we know about people. Does the therapy work? We don't know this. We have some people where we know the answer, we learn the rule, we apply it to Angela, and we know it worked for her. And it goes like this, right? That you have people here that, yes, they pay tax, no, they don't pay tax. And what we do, statistician, is to make this line, the rule, so that when Angela comes in, we can assign her to, yes, she pays tax. Is this good enough? We can do much better. Because here we are using only the few individuals where we know if they pay or not tax to make the rule. But look here, if I show you how all the individuals are, those here we don't know if they pay tax or not, but look how they lie in this beautiful space. Well, if I use all of them, I can make a much better rule. And now Angela, in fact, does not pay tax. So using all data and using statistical methods allows you to get much better information about what you're interested in. Back to you. You and the data revolution. I'm serious when I say it's a revolution. It's because the impact of data and the data-rich information technology is very deep, much deeper if we think carefully than we believe superficially. What is happening? Well, we work less. The Internet of Things. Machines do a lot for us. The boundary between work and free time is blurred, is not so clear anymore. And this weakens the power, the importance of a salary, which is a fundamental instrument. I see an economist there. I have to be careful what I say. But the salary is an important thing, right? At least. That should be right. The sharing economy, where we collaborate to produce things, is coming out. And this escapes the rules. Loppemarket starts soon again. There's no tax paying there. Nobody pays tax in Loppemarket. This is not part of the Norwegian GPD. It's not. So what about data? Who owns data? Who owns my health record when it is stored in the Oslo University Hospital? It's free, in fact. Data are very often open and free, and information is open and free. So this kills the concept of private property. We've heard this a couple of 100 years ago, something with private property. But it seems now that private property is in danger. And people are networked. We are connected together individually because we want to it or because we just are. And networking puts decisions in the hands of very many. And you've seen this in Turkey, in Brazil, in Tunisia, in many places in the world. Wikipedia is an example for you, a beautiful example. Maybe one of the most important examples that we have out there. The product they sell is for all and for free. And the guys that produce it are many people that do it for free in a collaboration. No profit, 200 employees, 73,000 people writing. People have analyzed this, and they say that if this would become commercial, if you would start to see advertising like you do on Google, then this would maybe make a $3 billion revenue a year. But it is impossible for any other company to enter that market because Wikipedia is there and it's for free. It's not easy to change the world because we have data. You should do it. So there are problems. The free market system, the free market society doesn't like this. There are walls built to protect intellectual property regulations. There are ways of restricting networks. It is clear that the using of my private data in a way I don't like makes me worry and makes me think that I might not want to put my data in the pot. The free market trying to keep data private, scarce, and sellable. And this is against academic thinking. This is against the fact that we share the responsibility to use the available data in full. Underutilization of data means slow progress, means public health that is not as good as we could today. So in Big Insight, our center, we shall use Telenor's Pakistan data to predict the spread of dengue fever in Pakistan. We should use DNB's financial transaction data to spot in the Norwegian economy whitewashing of illegal money. We will use Gjensidige's customer database to detect who of us is frauding, is asking too much when we make a crash with our car, which means that we all have to pay more in insurance. We will use ABB and Veritas data from hundreds of sensors that are on ship out on the sea to optimize the way they use energy in a better way. And we will use biobank data to give the right therapy to the right patient, cancer patient. There are lots of interesting things to read. Here are 3 books that I have in my pocket that I think are very interesting to read. The last one is just out. And yes, Big Insight, our center, is here, and we are really excited to join this voyage that happens with you to a better world. Thank you.
Takk skal du ha, Arnoldo. Du leder jo dette senteret Big Insight, og det er jo et senter som starter nå og skal I hvert fall leve I 8 år.
Ja.
Hva det morsomste du skal drive med neste år og årene fremover, som noen av studentene kan bli med på?
Det en senter hvor vi skal løse fantastisk interessante problemer. Jeg snakket litt om noe av disse. Vi skal lage statistiske metoder som hjelper å bruke disse data som allerede eksisterer, og som ikke fullbrukt. Det morsomt å jobbe sammen med veldig mange. Jeg snakker en dag med en fyr som kan om mobiltelefoner, den neste dag med en som kan om gener, og så den neste dag en som kan financial transactions. Og dere matematikere, statistikere, computer scientists, vi har dette fantastiske privilegium at vi kan bare bytte interesse litt, mens vi fortsetter å ha en core-kompetens som veldig mange trenger. It's a good choice.
Takk skal du ha. Og som Arnoldo sa, les statistikk og bli en del av dette her.